basic geometrical concepts, lines and angles. List of the topics that are dealt in this session are lines, angles, polygons, triangles and some practice problems. First of all, we will learn about a point. A point is used to denote location. It is denoted using always uppercase letters. For example, P, Q, R. These are the points. A line. Line is a collection of points which are drawn one after the other and can be extended infinitely in both the directions. Types of lines. Line segment, ray, straight line and curved line. A line segment is fixed at both the ends. It has a end points on both of its ends. Whereas a ray is fixed at one end and it extends infinitely in other direction, in one of the directions. A straight line extends infinitely in both the directions. There is no fixed point in a straight line. Curved line, by name itself, it is a curved line. Next is an angle. An angle measures the inclination of one line with respect to another line. It is measured in degrees. The units of measuring the angle is degrees. 1 degree is 1 by 360th part of a full circle. So the two rays forming the angle are called arms. So in the figure, OA and OB, these two are called arms, and angle is formed between the two arms. So the common endpoint of both the rays is called vertex. So O is a vertex of the angle AOB. Types of angles. So based on the measurement, the angles are classified. Acute angle. So if the measure of the angle is between 0 degrees to 90 degrees, it is called an acute angle. If the measure of the angle is exactly 90 degrees, it is called a right angle. Similarly, if one of the angle measures more than 90 degrees, that is between 90 degrees to 180 degrees, if the measure of the angle is between 90 and 180, it is called a obtuse angle. If the measure of the angle is exactly 180 degrees, it is called a straight angle. And if the measure of the angle is between 180 degrees and 360 degrees, it is called a reflex angle. If the measure of the angle is exactly 360 degrees, it is called a complete angle or full rotation. So these are the types of angles based on the measurement. Pairs of angles. If the sum of two angles is 90 degrees, then they are called as complementary angles. So example, here the two angles 70 degrees and 20 degrees, their sum is 90, so they are called complementary angles. 70 degrees is the complement of 20 degrees and 20 degrees is the complement of 70 degrees. Together they are called complementary angles. If the sum of two angles is 180 degrees, then they are called as supplementary angles. So example, 150 degrees and 30 degrees. Their sum is 180 degrees, so they are called supplementary angles. So these are the pairs of angles. Bisector. A bisector is something that cuts an object into two equal parts. So dividing an object into two equal parts is called bisecting. So here we have three types of bisectors. One is an angle bisector. Angle is divided into two equal parts. 40 degrees is divided into two parts, 20 degrees and 20 degrees. So the blue line is called angle bisector. Similarly, here a line is bisected into two equal parts. The second figure shows linear bisector. Similarly, the third figure shows linear bisector, and the bisector is making an angle of 90 degrees. So therefore it is called perpendicular bisector. The bisector makes an angle of 90 degrees, then it is called a perpendicular bisector. Intersecting lines. If two straight lines intersect each other, then they are called intersecting lines. So that means they have a common point between them. So here in the figure, lines L and M are intersecting at a point. So that point is called point of intersection. Perpendicular lines. It is a special case of intersecting lines. If two lines intersect each other at right angles, then they are called as perpendicular lines. So perpendicular lines are intersecting lines with an angle between them as right angle. So we say that L is perpendicular to M. So because they are intersecting at right angles. Properties of intersecting lines. So when the two lines are intersecting, at the point of intersection, four angles are formed. So here you can notice the four angles which are formed. So in these four angles, some angles are equal and some angles are supplementary. So let us see what are the equal angles. So here all vertically opposite angles are equal. So in the figure you can notice that angle X are vertically opposite, similarly angle Y are vertically opposite. So they are equal. Vertically opposite angles are equal. Adjacent angles are supplementary. So X and Y are the adjacent angles. So they are supplementary. That means their sum is 180 degrees. X plus Y is equal to 180 degrees. So they are called adjacent angles. So angles with a common arm are called adjacent angles. So X and Y, they are adjacent angles because they have a common arm between them. So they are supplementary, their total is 180 degrees. Parallel lines. Parallel lines are the lines which do not intersect at any point, even if they are extended. Distance between two parallel lines remains same at every point. So in the figure, lines L and M, they are parallel. They don't intersect even if you extend them to any length. And the distance between any two points is same at every point. Properties of the parallel lines. Here in the figure, lines M and N, they are intersect by a line. So that line is called transversal. So the transversal intersects the lines M and N, and at the point of intersection, four angles at the first line and four angles at the second line are formed. Total 8 angles are formed. So at line M, angles 1, 2, 3 and 4 are formed. At line N, at the point of intersection, angles 5, 6, 7 and 8 are formed. So out of these 8 angles, some angles are equal and some angles are supplementary. So let us see what are the equal angles first of all. So out of these 8 angles, all vertically opposite angles are equal. So here angle 1 and angle 3, both of them are equal because they are vertically opposite. Similarly, angle 2 and angle 4, they are vertically opposite and they are equal. The same way, angle 5 and 7, angle 6 and 8, they are equal because they are vertically opposite angles. and the corresponding angles are equal. In the first set of 4 angles, angle 1, and in the second set of 4 angles, angle 5, they are in the corresponding position. So they are called corresponding angles. They are equal. Angle 1 and angle 5, they are corresponding angles and they are equal. Similarly, angle 2 and angle 6, angle 3 and angle 7, angle 4 and angle 8 are the corresponding angles and they are equal. And also, interior and exterior alternate angles are equal. Interior angles are the angles in between the parallel lines. So in the figure, angle 3, 4, 5, 6 are in between the parallel lines. They are called interior angles. And angle 1, angle 2, angle 7, angle 8, they are outside the parallel lines. They are called exterior angles. The interior angles and exterior angles, alternate angles are equal. Alternate means one at the top and one at the bottom on the other side. Alternate interior angles are angle 3 and angle 5 and angle 4 and angle 6. They are equal. And similarly, exterior angles also, angle 1 and angle 7, angle 2 and angle 8. They are equal. Interior and exterior alternate angles are equal. So these are the 3 types of equal angles. Now let us see what are the supplementary angles. Supplementary angles are all adjacent angles are supplementary. You can notice here angle 1 and angle 2. They are adjacent angles. Adjacent angles are the angles with a common arm. 1 and 2, 2 and 3, 3 and 4, and so on. They are the adjacent angles. In the same way, the second set of 4 angles also, adjacent angles are supplementary. Their sum is 180 degrees. Next, second type of supplementary angles are co-interior and co-exterior angles are supplementary. So, co-interior angles are the interior angles on the same side of the transversal. Angle 4 and angle 5, they are co-interior angles because they are on the right side of the transversal. Similarly, angle 3 and angle 6, they are on the left side of the transversal. They are the co-interior angles. They are supplementary. Angle 4 and angle 5 are supplementary. Angle 3 and angle 6 are supplementary. Next is a polygon. A polygon is a closed figure formed by at least 3 line segments. So you can notice, you can observe some polygons here. A polygon with 3 sides, it's called a triangle. And next a polygon with 4 sides, which is called a quadrilateral. And next we have a polygon with 5 sides. Vertices and edges of a polygon. So edge is nothing but a side of a polygon. You can see in the figure. Vertex is a point of intersection of the sides. You can notice a vertex, which is also called a corner. Names of the polygons. So based on the number of sides, we give the name to a polygon. So the minimum number of sides is 3. A polygon with 3 sides, as we discussed, it is a triangle. Next, a polygon with 4 sides, this is called a quadrilateral. And a polygon with 5 sides, it is called a pentagon. Next is a polygon with 6 sides, it is called a hexagon. A polygon with 7 sides is called a heptagon or septagon. A polygon with 8 sides is called octagon. A polygon with 9 sides is called a nonagon. And a polygon with 10 sides is called a decagon. So these are the names of polygons up to 10 sides. interior and exterior angles in a polygon. So this is a polygon with 5 sides. So we have some angles colored in blue and some angles colored in red. The angles colored in blue, they are outside the polygon and they are called exterior angles. And angles colored in red are inside the polygon, they are called interior angles. Exterior angle is formed when one side is extended. The angle formed between the extended side and the given side is called an exterior angle. Types of polygon. There are 3 types of polygons. One is a convex polygon and the concave polygon, complex polygon. If all the angles are less than 180 degrees, that polygon is called a convex polygon. Each angle measures less than 180 degrees. If at least one angle, interior angle, is more than 180 degrees, it is called a concave polygon. And a complex polygon is a combination of 2 or more convex or concave polygons. Regular polygon. It is a polygon whose all sides have the same length and all angles have the same measure. So all the sides are equal and all the angles are equal. So then that polygon is called a regular polygon. So a regular polygon with 3 sides is called an equilateral triangle. So all the 3 sides are equal and each angle measures 60 degrees in the equilateral triangle. And a regular polygon of 4 sides is called a square. Similarly, a polygon with 5 sides, all equal 5 sides, is called regular pentagon. And a polygon with 6 equal sides is called a regular hexagon. Properties of polygon. Sum of all the interior angles. The formula is n minus 2 into 180 degrees. Measure of each interior angle of a regular polygon is n minus 2 into 180 by n. Sum of all the exterior angles is 360 degrees. Measure of each interior angle of a regular polygon is 360 degrees by n. So n stands for number of sides in all these formulae. Diagonals of a polygon. A line segment joining any 2 non-adjacent vertices of a polygon is known as a diagonal of a polygon. So in these polygons, the lines colored in blue are diagonals. So they join the non-adjacent vertices. So this is a diagonal and this is a diagonal. These are the diagonals in these polygons. The lines colored in blue are diagonals. And the total number of diagonals that can be drawn from any one vertex of a polygon is n minus 3. So n stands for number of sides. And the maximum number of diagonals of a n-sided polygon is n into n minus 3 by 2. So this is the formula to find out maximum number of diagonals in a polygon. So where n stands for the number of sides. Triangles. So a triangle is a polygon of 3 sides, 3 line segments. So it has 3 sides, 3 vertices and 3 angles. So this is a triangle ABC. AB, BC and AC are the 3 sides. A, B and C are the 3 vertices. And the 3 angles, angle A, angle B and angle C. Classification of triangles. So on the basis of length of the sides, triangles are classified into three types. One is a equilateral triangle, so which has all the three sides equal and three angles are equal. Each angle measures 60 degrees. And the second one is a triangle with two equal sides. It's called an isosceles triangle, and also two angles are also equal. Scalene triangle. No sides are equal and no angles are equal in a scalene triangle. So these are the three types of triangles based on the length of the sides. Next, on the basis of the measure of the interior angles, again the triangles are classified into three types. The first one is acute angular triangle. So that means all the three angles are less than 90 degrees in an acute angular triangle. Next, the second one is right angle triangle. If one of the angles of the triangle is a right angle, that means 90 degrees, it's called a right angle triangle. Next, the last one is obtuse angular triangle. So if one of the angles is more than 90 degrees, so that means if one of the angles is an obtuse angle measures more than 90 degrees and less than 180 degrees. So then that triangle is called obtuse angular triangle. So these are the types of triangles based on the measure of the interior angles. Sum of all the angles of a triangle. Sum of all the interior angles of a triangle is 180 degrees. So you can see the example here. The two angles, given angles are 70 and 30. The unknown triangle is 80 degrees. Sides length restrictions. So the condition to be maintained by a triangle for the lengths of the sides. So the two conditions are: sum of lengths of any two sides of a triangle must be greater than the length of the third side of the triangle. That's the first condition. Next, the second condition is difference between lengths of any two sides of a triangle must be less than the length of the third side of the triangle. So in the example, the two sides of a triangle are 10 and 3 units. The third side x must be between the difference and the sum of the two given sides. The difference is 10 minus 3, which is 7, and the sum is 10 plus 3, which is 13. The length of the third side must be between 7 units and 13 units. So that is a condition for the length of the sides to form a triangle. Ordering of sides. In any triangle, length of the side opposite to the largest angle will be the largest. Similarly, in any triangle, length of the side opposite to the smallest angle will be the smallest. So you can notice here in the example, angle 70 degrees and 60 degrees are the two given angles. Third angle will be 50 degrees, because the sum of the angles must be 180 degrees. So therefore, the smallest angle is 50 degrees. So Z is the smallest angle, and next highest angle is 60 degrees. So X is the next highest longest side, and the longest side is Y. So the ascending order of the sides is Z, X and Y. So the side opposite to the smallest angle is smallest, largest angle is longest. Right angle triangle. So a triangle which has one of the angles as a right angle is called a right angle triangle. We have seen in the classification of triangles. So this is a right angle triangle. The perpendicular sides are called legs, and The line joining the perpendicular sides is called hypotenuse, and hypotenuse is the longest side in a right angle triangle. So the theorem which is obeyed by a right angle triangle is called a Pythagoras theorem. Pythagoras theorem states that in a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the legs. So in the given right angle triangle, A and B are the legs and C is the hypotenuse. So square of the hypotenuse, C square, is equal to sum of the squares of the legs. So that is A square plus B square. Pythagorean triplets. So the standard measurements of a right angle triangle. Pythagorean triples are the triples of three integers which satisfy the Pythagorean theorem. So in the right angle triangle, A and B are the legs and C is the hypotenuse. So the measurements, standard measurements are A, B and C are given in the given table here. 3, 4 and 5 is one triplet. Legs are 3 and 4 and hypotenuse is 5. They obey the Pythagoras theorem. Similarly, 5, 12, 13, 8, 15, 17, 9, 40, 41. And the equivalent ratios of all these sides are also called Pythagorean triples. Similar triangles. Two triangles are said to be similar if their shapes are similar. Sizes may or may not be. So in the given figure, triangles ABC and triangle PQR. So they are similar. The corresponding angles are equal. Angle A and angle P are equal. Angle B and angle Q are equal. Similarly, angle C and angle R will be equal. And also the corresponding sides are the same ratio. Ratio of AB and PQ. Ratio of BC and QR. Ratio of AC and PR. So all the ratios are equal to 2:1. That is 2 by 1. So this is a property of the similar triangles. Area and perimeter of any triangle. Area of a triangle, the formula is half into base into height. Perimeter formula is sum of lengths of all the three sides. Special right angle triangles. So this is a right angle triangle. One of the angle is 90 degrees. The other two angles are 45 and 45. So the three angles are 45, 45 and 90. So in such triangle, the ratio of the sides is x and x root 2. So if the two angles are equal, two sides also must be equal. It's called a isosceles right angle triangle. So the two equal sides are the legs are the two equal sides, x, and the hypotenuse will be x root 2, root 2 times of the side. So the ratio would be 1:1:root 2. Next is 30, 60, 90 triangle. So in this triangle, the ratio of the sides is 1:√3:2. So the side adjacent to 60 degrees is x, and the side adjacent to 30 degrees is x root 3, and the hypotenuse is 2x. Equilateral triangle. Equilateral triangle is a triangle with all the three equal sides and three equal angles. So three equal sides are A, and all the three angles are each equal to 60 degrees. So height of a equilateral triangle is √3/2 A. A is a side. Area of an equilateral triangle is root 3 by 4 A square. Regular hexagon. So regular hexagon is a hexagon with all the 6 equal sides. So it can be divided into 6 equilateral triangles by joining the opposite vertices. So that means by joining the opposite vertices with 3 lines, 6 equilateral triangles are formed. So area of each equilateral triangle is root 3 by 4 A square. So there are 6 equilateral triangles. So therefore area will be equal to 6 times of root 3 by 4 A square.
Let us solve some practice questions. So in this question, we can see that the circle above has center O and is divided into 9 equal arcs. What is the value of x? So angle at the center of a circle will be 360 degrees. It is divided into 9 equal parts. So we should divide 360 degrees with 9. So which gives 40 degrees. So the angle x is made with 4 parts. So 3 parts. So that means the angle x is equal to 40 into 3, which is equal to 120 degrees. So next question. In the figure above, point B lies on AD. What is the value of 3x? So the line is AD. So that means angle at the point B is 180 degrees and angle ABC is 90 degrees. So this is 90 degrees. And the other side also we should have 90 degrees. So sum of all these 3 angles must be equal to 90 degrees. So that means 2x plus 2x plus x. Sum of all these 3 angles must be equal to 90 degrees. So this is equal to 5x is equal to 90 degrees. X is equal to 90 by 5, which is 18 degrees. So the question is to find the value of 3x, which is 3 into 18, 54 degrees. The value of 3x is 54 degrees. The next question, so in the given figure of pentagon ABCDE, points F, A and B lie on the same line. What is the value of y? So FAB is a straight line. So that means angle A will be 180 degrees. So this angle EAB is equal to 180 minus x. And sum of the 5 angles in a pentagon, ABCD is a pentagon. Sum of the angles in a pentagon. So sum of the angles formula is n minus 2 into 180. Which is 5 minus 2 into 180. This 3 into 180, which is equal to 540 degrees. Sum of the angles in a pentagon is 540 degrees. So what are the 5 angles in this given pentagon? So one angle is x, the other is y, 113, 180 minus x plus 132. Sum of all these 5 angles is equal to 540 degrees. Plus x and minus x will get cancelled. So if you add 113, 180 and 132. 425 plus y. So y is equal to 540 minus 425. Which is 115. So value of y is 115 degrees. So let us move on to the next question. So in the figure above, RT is equals to TU. RT is equals to TU. What is the value of x? So he is asking to find the value of x. So in this figure, RTU, the triangle RTU is an isosceles triangle because the two sides are equal. One angle of this isosceles triangle is 114 degrees and the other two angles, angle R and angle U, they are equal angles. The angles opposite to the equal sides are equal. So therefore 114. So let us assume this angle R and angle U as y degrees is equal to 180 degrees. So 114 plus 2y is 180. So 2y is 180 minus 114. Y is equal to 33. This is 33 degrees and here also we have 33 degrees. Now consider triangle SVU. In triangle SVU, we know the two angles. One angle is 31 degrees and the other angle is 33 degrees and another is angle V, SVU. So sum of these three angles is 180 degrees. This is 64 plus angle SVU is equals to 180 degrees. Angle SVU is equal to 180 minus 64, which is equal to 116. And angle X is equal to 180 minus 116 because both of them are on the same straight line, which is equal to 64 degrees. Therefore, the value of X is 64 degrees. So let us move on to the next question. So in the figure above, which of the following is greatest? So the two angles are 60 degrees and 70 degrees. The sum of the two angles is 130. So therefore the third angle must be 50 degrees. Angle A and 60 degrees, they are vertically opposite. So therefore measure of angle A is 60 degrees. Angle B and 60 degrees, they are supplementary because they are adjacent angles. So angle B is equal to 180 minus 60, which is 120. And angle E is equal to 180 minus 70, which is 110. Angle D is equal to 180 minus 50, which is 130. So the greatest among all these four angles is 130 degrees, which is angle D. The next question. So in the triangle above, which of the following must be true? So the two given angles are 80 degrees and 30 degrees. The sum of the two angles is 110. The third angle must be 70 degrees because the sum must be 180 degrees. So the greatest side is opposite to the greatest angle. So therefore 4 plus P is the greatest angle, greatest side. Next greatest is opposite to 70 degrees, which is 4 plus R. And the least is 4. So 4 plus P is greater than 4 plus R. So if 4 is subtracted on both the sides, this gives P is greater than